Hello and welcome back to Compiler Programming. In the last video we started working on a tokenizer, and today we are going to be continuing this work and hopefully getting in a few more token types and generally improving the algorithm that we are using to do that. So right now we are in a pretty good state. We can parse or tokenize numbers, or at least sequences of digits, because there might be some nonsense numbers, something like this, which depending on the semantics might be okay, might be not, but that's not important at this particular stage. We can also do identifiers, including identifiers that have numbers, and we can tokenize a plus sign. Before I go in and start doing more things, I would like to do some changes to how this is done, and in particular, we are actually going to make use of one of the features of C language that is gets a lot of flag for being bad and whatnot, but this is a goto. And the reason we want to goto, because if you think about this logic of handling closing brace, or in fact any logic of what happens once we are out of the token, then we basically go through the code. So let's just say we go through this line, right? And we are considering the case as a ID, not a keyword, but so we go through it, and we come across a space. So right now, this is how we do it, right? When we come across a space, we say that we finished with a token and we need to push it. But it also might not be a space, right? It might be a semicolon or whatever else. So generally, a better way to handle this kind of stuff would be to go through the token and check if what we have is something we can use for a token. And once we come across something that we have no idea about, for example, a space, we push the token, switch to the default state, but then don't actually advance the input and go again with the default state. Now, I could remove this whole switch state and the whole loop and replace all of it with goto, but I think it might be a bit hard to follow, and this is why people generally advise against using gotos. But I think if I just use it to kind of redo the loop without advancing, then it's okay. Another way I could do it is, I guess, by just doing this plus plus in a certain place. So for example, at the end here, instead of at the very instead of inside of the for, and that would afford me, if I do like a continue, then it wouldn't advance. But I think it might actually be harder to follow in this case. So let's just do something like retry, and this is a label for the loop. Okay, and this is what we will do. We will say that if it is a digit, then we continue. If it is not a digit, so we, instead of asserting here, we will just say state is default and go to retry. And this way, we will now end up in this part. And here we still have this assertion that if we don't know what to do with this stuff, then it is something we cannot tokenize. So it still will be taken care of. Okay, let's change our ID and operator to be exactly the same way. In fact, as far as operator goes, it should just immediately do this stuff. So it should immediately go into the default state. Right? A bit later in this video, I'll probably change it to be more useful than just doing the plus, but for now, this is all it needs to do. Okay, and And here is another one. So let's, we actually don't even need this break because it will always be false, but it's fine. Let's take this stuff and put it over here, remove this is space. So let me look at it. So now the logic becomes a bit more straightforward. We're just saying, okay, is this still a digit? Then we continue, otherwise we push and we retry with the default state. Now before I try to run the test, I also want to actually move this stuff here. Actually, I probably to format it like this, so it is more obvious where the label is pointing to. And here we want to do else if and deal with this code here. So if we come across a parent, then we do all of this stuff and we don't need to continue now because we are in the right place. We also would not need to change state because if we ended up in here, we were already in the right state. So let's see if this actually works out. We might need to debug a bit, but that's okay. Okay, so something is not right with our groups, but besides that, everything seems to be fine. So what would be wrong with our groups? Let's, yeah, actually, I had some changes maybe accidentally, so let's try that again. No, the problem is we have parent children, length is 1. Okay, so this is the stuff that fails. Let's open our dev environment or Visual Studio and look at what we have there. Solution Explorer, let's check that they are debugging the right thing. We are not, so we can do this and we can look at this test here and see what is going on. Okay, so root actually correctly has things. Now we can look at parent. So it has 2 children. That is very interesting. So which children does it have? Parent, children, data, items 0, something like this. Yeah. Sorry, one of them is a dot and the other one is arrow. Okay. So this one is ID. This is X, which seems fine to me. And the other one is what? The other one, we can take this and change it to 1. So we managed to push the same thing twice. And I think that is because we no longer need to do this push here. So let's see if that is correct. And rerun the tests. Okay, that is pretty good. So this has, as I said, several advantages. First, it's more correct, it is shorter, and it is easier to deal with in general. Now, in the long term, we can also consider if we could like abstract this away even further, because these things all have very similar structure. So we definitely can either use macros or even use something more funky, like just associate, for example, a function pointer with each of the states, and the function will do this check for us. So like if we should continue, then it is continuing, otherwise it doesn't. But for now, this is pretty good. Maybe I will turn this into a macro and say that define push and retry, and this thing will do this stuff. Actually, we probably should wrap it in do while. It's just a good practice for macros, because otherwise you may end up in a situation where you expect the macro to be a single statement where it turns out to be multiple ones and you end up in trouble. So this is just a better way to do this. We remove actually a semicolon because it also forces us to put a semicolon. We say push and retry. And the reason I put this do while is because now we can do it this way and it will still work, which is pretty nice. But I will keep the braces because I like that style more in general. Let's see if this is working now. Okay, great. I think now we have a pretty good setup for stuff. One more thing that we can try to turn into a macro, I guess, is to have something like start token, and we will give it a type, and it will do this stuff. So it will give it a type. Yeah, that sounds good to me. So let's do that. I'm wondering, I think that actually can be a proper function. Yeah, let's create one. So it's a token star token make, and then we say token type. Is it called token type? Yes, it is. And once we have that, we can do this stuff and say that token star result is this. And we create things, we put here, we put type in the right place. We also need to specify a parent. So I guess it can't really be a function, but it's fine. Let's make it into a macro. That also works. Define start token, and this accepts a type. So let's put this stuff back. We allocate a token, but here we say again do while, like in the other macro. While 0. Okay. Say current token is this thing. Okay. That sounds good. We put type over here. Parent is just something we get out of a global variable, so that's fine. And we are missing a few slashes at the end. So this should do it. First, let's try to build without using it. That works. So we can say start token type integer, and I guess we could I'm sort of wondering if we even need these states, but I will keep them around for now and see what I want to do with them later, because it might be that we could use token type as a state directly. So this is integer, this would be ID, This would be an operator, and this would be a parent. We also need to change something for parent, which is it needs to have an array of children. So for now, I guess let's do it this way. We just do it like that. Okay, that seems good to me. Let's see what is going on. Okay, we are missing a semicolon somewhere, and in particular, it is over here. Let's see if it still works. It does. So now I'm pretty happy with this. We have very straightforward logic, and it's very easy to add stuff to it. Okay, so let's add more tests. And in particular, what I want to do is the way I want to tokenize this language is that sequences of similar things are considered one. So like if you have plus, that is an operator. If you have plus plus, it is a single operator, and if you have triple plus, it is still a single operator. So there is nothing like in C where this would be a sequence of two operators, because we know that there are two operators. I want this tokenization to be very straightforward. Like if you want two operators, and just put a space between them. There is no like this weird thing with predefined set. And yes, if we don't find that this operator doesn't exist, well, it doesn't exist. It makes the tokenization step easier, and I would argue it also makes the life of the users also easier. Okay, I'm not actually gonna add new tests. Instead, I'm gonna now just add a bit more operators. So we will use like divide, minus, and multiply. So we need to do something about this stuff. Okay, before I forget, I should also undefine the macro that we created. It's just a good practice to be hygienic, because macros are global. You should try to kind of clean up after yourself, and if you create this local macro that are only useful for one function, well, just remove them afterwards and treat them as a scoped thing, as you would for any other variable. Okay, now we need something like code point is operator. And I'm calling it code point and not char, because eventually we would want to deal with Unicode code points, which are larger in size, so they are 21 bits, usually represented as a 32-bit integer. And because of the rules of implicit casting, we can very easily pass a char to it, and it's not a problem. Okay, so for now we'll just say that operator is one of the predefined code points. So we'll just do something like this. We'll switch of code point, and we say case plus, and then we add a bunch more cases. So we say plus, minus, equals. I'm just looking at my keyboard. What else I want to make an operator? This stuff. Not sure. I guess percent. This thing, ampersand. This stuff. What else do we need? Divide, right? Colon, semicolon, comma. What else do we have? I guess question mark goes into here as well. And I think I'm almost out of things that are operators. Maybe I'm forgetting something, but that is okay. So in all of these cases, we return true. And in case of default, we return false. There might be faster ways to do this, but for now, this is okay. And now we can use this function in place of this comparison with plus, and we just say if it is an operator, then we do this. And now our operator will become exactly the same as everything else, where we say while it is remaining to be an operator, we continue. If it stops being an operator, well, we do something else. We don't need this stuff. That looks good. Let's try to run the test and see if this works. And indeed it does, which is great. So now we have operators, and I want to try some more complex ones. So in some languages, this is to the power. So let's see if that works. And it does. Great. So we just tokenized all of the operators, or majority of operators that we will need, which is good news. Okay. What is so what are we going to do next? Well, next thing is actually dealing with braces in a better way. Or maybe not. Let's do strings first, I guess, before we do braces. So strings are a bit different, and in the sense that, well, actually how we set up things are not so different. So let's just create a test and say it should be able to tokenize strings. And now we'll have to do some escaping, and we say foo space 1, 2, 3. We tokenize that, we verify that it has one child, we get the child, and then we verify the slice. So it should be like this. And it's not a parent, it's a string. Okay, so we will need a new state for string, but with string it is actually kind of interesting, because it is sort of an open-ended thing, but it must end a specific character. That means that we will, for one, the condition here is sort of the inverse, where we say if it is not, so if char is not a double quote, then we do this stuff, right? And secondly, here, ideally, we should say to do check for unterminated string. So what I mean by that, if we end up like this, where we don't have a quote at the end, we should also catch that and say, actually, this is not valid. We were expecting a fully formed string, but we just got an end of file and it's not great. Okay, so what is that then? That's fine. We do need to add this state here. And that would be good. And now we need to add this state to here and say if we are here, we start on a string and we go to the string state. This is fine. And I think we are good. Apparently we are not good. So let me retrace my steps and see if it makes sense. So we have this push and retry, and I think I want to split this. So I want to just do push, and go to retry will be a separate thing. So it will be like push, go to retry. And the reason is because here we actually don't want to retry. We want to, so when we find ending double quote, we still want to increment this, and we want to push but not retry. So let's change this stuff and see if this works better. Still no dice. So let me think about this. What is happening? We are pushing, we are breaking. So that seems good to me. Well, I guess it is time to see what is going on. Yeah, we are failing in strings. Let's see. We don't need this anymore. We only need this one. So root, children, data. Yeah, we have definitely 2 children. Let's see what is our second child. So this is right about what I would expect. Oh, I see. That's actually kind of interesting. So we also have this situation where we should say that current token is 0, right? Because we just pushed it and there shouldn't be one. The problem is we are getting to the end and then we are still pushing that thing, which is not really what we want to be doing. Yeah. In all other cases, it was working fine because when we were going into here and this thing was creating a new token, but this is a more robust way to deal with it in general. So that should be better. And it is. So now we have strings. Now, I mentioned in the previous video that I'm still not sure about how to deal with escapes. Honestly, I'm not a big fan of them anyway, because they are quite ugly to type. They are quite ugly to understand, and it is also pretty nasty to parse them. So I'm still thinking if there might be a better way in the language to represent things like this, but I am not entirely sure. So for now, that will be okay, and I'll figure out later once I do need the escapes. I will implement it at that point in time. Okay, so we have integers, we have operators, we have identifiers, we have this stuff, we have sort of braces, we still need to work on them. What else would we need? Well, we need to have comments, and this is where it is a bit interesting. So we go into a territory where the same character can be interpreted in multiple ways, right? It can be so let's say we have comments like in C, and you have this stuff. So the problem here is that this is also a division. So is it like 2 divisions in a row, or is it a comment? And in general, there are a couple of ways to deal with this stuff. One way is to implement a look ahead. So basically to say, okay, I'm gonna be now on a slash, and I'm also looking forward and checking, oh, is the next thing also a slash? If that's the case, then I know I am on the I'm on a comment, and I will act accordingly. Another way is to encode these into states, and when we come across a slash, we go into a special state where we like, I don't know what it is. It might be a comment, or it might be division, and then deal it inside of this state depending on what we will get. I'm not entirely sure which option to go to here. I guess I will go with picking forward and see how it feels like. So pick is I can do it right away and say S8 pick, and this would be I less than source length. So I plus 1 less than source length. Then I would like it to be source bytes I plus 1. Otherwise, it is 0. So this is, I'm not sure if this is the most efficient way to do it, but it is fine because now we can pick one character forward and we can do some logic based on it. So here's also where the order becomes important, because slash is also part of the operators, right? So if we want to do special logic on slash, we need to do it over here. And we need to say if char is slash and pick is slash, then we do something. And what do? Well, we do new state. So this is one of the things about having these kind of hand-coded state machines, because the whole job is not very complicated. You just create new thing, create new new state, and that's it. Now, one thing with comments is we are going to skip them, which is very common in tokenizers. Again, depending on what you will want to do later with the source, you might want to keep them around, but they are not important for program execution, so we will just ignore it. And that means that we will not start a token, we will just change the state. So we'll just say state is this thing, right? Okay, what does it do? Well, let's think about this. If we are in state of a single line comment, then we have another complication which arises from line ending format. So in Windows, line ending is actually 2 bytes. It is /r/n. So carriage return and line feed, I believe they are called correctly. In some older Unix system, I think it was just this, and in Linux and macOS right now it is /r. No, sorry, /n just. So this is one of those annoying things when dealing with text file and the legacy of them, that people still haven't agreed that this will be the right way to do it. So you have to account it in your tokenizer. The strategy here is basically exactly the same as above in here, but it just makes it slightly annoying to to do this. So here's what we want to do. If ch is /r, then what? If pick is /n, then we push. Or actually, we always do we need to push? No, we just need to change state. So we always say state is tokenizer state default, but if pick is /n, then we skip over a character. That seems reasonable. Okay. If ch is /n, then we do sort of the same thing. Yeah, that sounds good. And that's what I'm saying. Like, it's just kind of buggy. Very often it's buggy and it's annoying to deal with this, but this is something that you have to do. So just to reiterate what's happening here. Again, we have 3 options: just /r, /n, and /r/n. In all of those cases, we want to end. The only interesting one is the double one, where we have /r followed by /n, in which case we skip an extra character. Hopefully that makes sense. So let's figure out if that is okay. Yes, we recognize a comment. So we say /foo /n. Actually, without /n it also should work, but let's see. And it still should be exactly 0. Let's try. Okay. And just like this, we can do single line comments. Multi-line comments are basically the same. We can also implement them if we want to, but they are the same thing as we have here. So let's go with something more interesting, which actually requires some thinking. And in particular, that would be braces. So what is it about braces? Well, we already have this logic here. However, we also want to detect that we have misbehaving braces. Should be able, I will for now just create a new one and should be able to tokenize nested groups with different braces. So let's think if that makes sense. I guess, yeah. And I will remove this stuff, or no, I'll keep it around. So we want something like this to work. And I guess this is where we will start with. So this is like this. We'll call this one curly and change the token type here to curly. And this one would be square. And the token type will be square. And the length of it will be 0. And the source of the square will be this stuff. So this is what we expect. And let's just make that work before we continue. Here it should be parent and here should be square. Okay, so that works. Let's try to run tests. They will fail. Yep, now we don't know what to do with that input. How do we deal with this? Well, it is pretty straightforward. So we say if it is an opening parenthesis or it is this one or it is a square one, then we do this stuff. We do need to do different token types. So what can we do? Well, we can actually do a trick where we assign enums to this stuff to have a repetition, but we can also just do this. Token type is something like this. Token type like so. This is gonna be square, and this we actually don't need. We just say token type. Actually, this one is square. The other one is curly. Okay. So we start talking of this type. That's good. And here basically is the opposite, right? Where we just say if we come across the closing one, then we pop the stuff. And that might even be all that we need to do to make it work. Yeah, I think that's actually it for the base case. Okay, that is fine, that is good. However, there is a problem. And the problem is if we do this, then things start to go bananas. Well, we don't get what we expect, but what we should be getting is an error because this is just invalid. Like we don't support this. So how do we deal with this stuff? Well, I guess when we come across one of the closing ones, we need to figure out if the opening one is the right one. And this is pretty much so the same logic as here, but in reverse. And we are saying that switch of token type, parent type, and we say case token type parent. We assert that ch is this. And break. If it is curly, then we assert that it's this, and square, we assert that it is square, and with default, we assert something went really wrong here. Char or group or something like this. I'm not sure how to correctly say this condition, but this is something that really should not happen. Let's say internal error. Like this is not something that should ever happen. This is a warning I'm not sure I want to deal with, but I guess I will have to. I don't want to disable those warnings for now, because in general they are good. I could switch it to not be a switch statement. So what it's complaining about is that I'm not explicitly handling all of the all of the states, and I guess it is a good thing to do, so let's just do it. Sorry, let's go here, operator. Actually, that's not state. I'm taking the wrong one. It should be this one. So we have token type ID, we have token type integer, operator, string, and I guess module. So let's see if it likes it like this better. It does. So let's try to run it now. And now we have assertion failure. Again, at some point we would want to not assert here, but instead like throw an error or return an error from Tokenizer saying like this is something really fishy going on here, so I don't know how to tokenize this. Please take a look. And reporting error is the whole thing in itself because as you can see, Tokenizer doesn't really care about lines. It just tracks the index in the byte array. But when we want to present an error to humans, we want to have a line number and column number so that they know how to deal with it. But it requires a bit of stuff to deal with it. So let me think if I want to have something else. Well, I guess not. The only thing I'm considering now is to try to have like a really complicated thing. So as far as syntax goes in general, I think I will use something like what Jai provides from Johnson Blow. I think it's a very neat syntax. It's very consistent. So I'll start with that, and if I figure out they want something else, then this is what it will be. So let's just say that I will have for, which is a function from x that is s8, and it, here we will add a /n. So here we would say return x plus 3 /n, and we have a closing stuff. So something like this should totally tokenize complex input. And I want to put it as the last one because everything before it needs to be successful if this is to be successful. So this should be fine. Let's take a look if it can tokenize the stuff. Okay, so this is interesting. Apparently it cannot, and I think I know what is the issue. Yeah, so the issue is here I forgot to add these two. Here we go. Great. Cool. So with that, we have a pretty capable tokenizer. It is also not a slouch. It is pretty fast, I believe, because it never backtracks. It has only one byte of look ahead. So this thing will carry us for a bit. Now there is one final thing to deal with this unterminated string. So let's do that right now. So we have this full as test, and we want this test to crash with assert. And right now it's just a failure of mismatch. So here we say if actually it's not even just string. What should happen? If state is a string or state is a line comment, then this is correct. or line comment we can actually allow to go to the end. Yeah, I guess it is a string, and when we implement multi-line comment, it will have the same setup. So if state is tokenizer state, we can just do assert. State is not tokenizer state string. Strings need to be terminated with a double quote. Cool. Let's try it out. Yeah, now we have an assertion failure, which is exactly what I expect. And that wraps up what we have for today, I guess. Let's recheck, and everything is fine. It is indeed fine. We are ready to wrap up. So thank you very much for watching, and I hopefully see you next time when we probably will deal with errors for the tokenizer, which I mentioned are quite an interesting thing to do. For now, goodbye.